Good morning everyone. My name is Varisha Fatima and my topic is dual space, covariant, contravariant and mixed tensor. So now we will study dual space or conjugate space. If VF is a vector space, then the set of all linear functions on VF is known as dual space or conjugate space of VF. It is denoted by V dash or V cap or V star. Or we can say that the set V star of all linear functions f defined on a vector space Vf is a vector space over f with addition and scalar multiplication defined by f1 plus f2 x is equal to f1x plus f2x for all x belongs to V, and af1x is equal to af1x for all a belongs to f, where f1 and f2 are linear functions on V. This vector space V star is called the dual or conjugate space over F. Now we will study about dual basis. Basis of dual space of vector space Vf is known as dual base, or we can say let V be an n-dimensional vector space over the field f and B is equal to alpha 1 alpha 2 dash 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 alpha n be a ordered basis for V, then there is a uniquely determined basis B dash is equal to f1 f2 dash 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 fn for V dash such that f1 alpha j is equal to ij. Consequently, the dual space of an n-dimensional space is n-dimensional. The basis B alpha is called the dual basis of V. f1 alpha j is equal to 0 if I is equal to j, or if there will be 1 if I is equal to j. The value of I is not is equal to is 0 and I is equal to j is 1. f1 alpha j is equal to ij, where ij belongs to f is Kronecker delta. Now we will study about covariant, contravariant and mixed tensor. Contravariant, let aij ij is equal to 1 2 3 dash 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 n be n square functions of coordinate x1 x2 and x dash 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 xn, and let these transform to a dash ij in another coordinate system x dash 1 x dash 2 dash dash xn. According to the rule, a dash ij is equal to a alpha beta differentiation x dash I dot differentiation xij upon differentiation x alpha into differentiation x beta. This will be our first equation. Then aij are called components of a contravariant tensor of rank 2. Similarly, covariant, if aij ij is equal to 1 2 3 dash 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 n be n square functions of coordinates x1 x2 dash 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 xn, and if aij in another coordinate system x1 x dash 2 dash 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 xn, by rule a dash ij is equal to a alpha beta dot differentiation x alpha dot differentiation x beta upon differentiation x dash I dot differentiation xij. This will be our second equation. So aij are said to be covariant tensor of rank 2. Now we will study about mixed tensor. Mixed tensor is let the n square function aij ij is equal to 1 2 dash 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 n of coordinate xi be transformed of aij in another coordinate system xi x dash I. According to the rule aij is equal to a alpha beta differentiation xi x dash I differentiation x beta upon differentiation x alpha differentiation x alpha j. This equation we will consider it 3 equation. Then aij are said to be components of mixed tensor of rank 2. Thank you.